In the last slide, we discussed direct proportions. Now we're going to take a look at inverse proportions. So inverse proportions are two quantities are inversely or indirectly proportional if a change in one quantity produces a change in the other quantity in the opposite direction. Let me fix this a little bit. Okay. In the opposite direction. In other words, if one increases, the other decreases, or if one decreases, the other increases. For inverse inverse proportions, thinking about these applications, some ways to look at it is the smaller gear will rotate faster than the larger gear, or a larger work team will get the work done in less time than a smaller crew. Okay, those are inverse proportions. Some applications of inverse proportions are the revolutions per minute of two mesh gears are inversely proportional to the number of teeth on the gears, or the amount of time to complete a job is inversely proportional to the number of workers performing the work. The larger the workforce, the less time it takes. See, one gets bigger as the other gets smaller. Graphically, inverse proportions usually look like this. Okay, it shows as X is increasing, you can see Y is decreasing. Okay, so when constructing inverse proportions, you position the corresponding terms on a diagonal. That's different than direct, okay, where we said corresponding terms numerator to numerator, denominator to denominator. For inverse, again, position corresponding terms on a diagonal. The numerator of one fraction corresponds to the denominator of the second fraction, or the denominator of one fraction corresponds to the numerator of the second fraction. So as a student, this is a good time for you to slow down when doing these problems, okay? First thing you would do is say, okay, is this direct or inverse? Once you know it's direct or inverse, then go look at the slides for hints, okay? So two meshed gears have 20 and 16 teeth. If the smaller gear rotates at 50 revolutions per minute, how fast does the larger gear rotate? So if the two mesh gears have 20 and 16, smaller gears at 15, okay, so that means that 16 teeth. Well, let's just set this up, okay? If two mesh gears have 20 and 16 teeth, if the smaller gear rotates at 50 revolutions per minute, how fast does the larger gear rotate? Well, the larger gear would be the 20, right? So we're going to say 20 teeth over the 16 teeth. Now, this is inverse, so the numerator of one fraction corresponds to the denominator of the second fraction, okay? So it's going to be 50 over x. From here, it's just cross multiplication. So 20x will equal, let's see, what's 16 times 50? That's 800. Divide by 20 to get an answer of x equals 40. Okay, take some time to look at how we set this up. It's really important to understand that the numerator of one fraction corresponds to the denominator of the second fraction. So the teeth of one of these meshed gears corresponds to, let's see, the revolutions per minute of the other one. Okay, and that makes sense. Okay, because the more teeth you have, the more revolutions. Would it be the more revolutions per minute? Yeah.